Yeah, I guess that also links with 8, so which I already did.
Okay. You could verbalize it, I suppose. There can't be too many things missing other than the interest rate kind of compounding. If you can tell me both of those, we could probably work it out.
Yeah. Yeah, I'll just send you a picture.
All right.
It's easier.
Yeah. It actually is in this day and age. It's
Yeah.
so easy to do.
Okay. You should be getting it soon.
Yeah, just
Or like,
tell me when it says file sent on your end, and then I always get it about 10 seconds after that. But it always has to say file sent. There it is, right there.
yep, there you go.
Yeah. So your muscles feel any less sore today?
They do actually.
Do they? It's getting better? Yeah, it should.
Yeah.
It'd be a shame if you had to go through the whole year feeling like that.
Yeah, I'm getting used to the workouts that we're doing.
Yeah,
So my legs sore.
yeah. That's didn't get better. I don't think anybody would play sports. All
Yeah.
right. So 8, 9, 10, and 11 are all based on 8. Huh? Okay. So they're nice enough to give us that. What kind of compounding is that?
Continuously.
Okay. So how do you do number 8? Tell me what to fill in.
So the P is 5,000 times E time or to the power of 0.06 times 15.
Okay. What's your calculator give you for that answer?
12,998 or 298.
Now let's see if that passes the ballpark test. Yeah, 5,000 initially has more than doubled after 15 years. Actually seems a little short. Uh, what's e to the 0.9 power?
E to the 0.9.
Mm-hmm. Yeah, no, that'll be right. Yeah, no, that's going to be right. That's got to be less than 2.7, right?
Yeah.
Yeah, okay. All right. I thought money that was earning 6% interest doubled every 7 years, but apparently not, because then it would have doubled twice and it would have been worth 20,000. I'm not sure where I ever got that. All right. So how long will it take the balance to reach at least 17,000? I guess you could say 17,000. Tell me the formula to write.
So 17,000. So I guess it's just 17 because I think A is in thousands. No, it's still 17,000.
Yeah.
Equals 5,000 E to the, is it the same thing? So 0.06
Only
times
this
50.
time the variable we're solving for is in the exponent. In the first problem, we were solving for that. So you could just plug it into your calculator. You can't do that now. What do
Okay.
you have to bring into play to solve this? Whenever you're solving a variable that's in the exponent,
Uh,
what is required?
that you what is it called? Isolate it.
What are you going to have to use? It starts with an L.
Logarithms.
Yeah. You always have to solve exponential equations using logarithms. Okay. So, you're
Okay.
right. We do want to isolate that first. So let's do that.
So divide by 5,000. Yeah, divide by 5,000,
Okay.
which is
So we can just, well, we'll just write it like that. Okay. Now,
okay. And so let's do a natural log of
of
both sides.
both sides, correct. Left side stays like that. Right side becomes
Um, 1, right?
natural
So,
log of E is 1. But I got to bring this exponent down onto the algebra line.
oh, right. So it's 0.06t.
Okay. Times 1. In other words, that is 1. Okay.
Yeah.
Now T is what?
Because the ln 3.4 divide by 0.06.
Yep.
Here, hold on. I think I might have done it wrong. 3.4 divided by 0.06.
You know the answer has to be more than 15 years, don't we? Because at
Yeah.
15 years, it was only at 12,000 something. So.
Okay. So I did it right. So it's 20.396.
I have no idea how many places he wants you to round it off to. That's why that's actually a preferable answer. What I just circled,
Uh-huh.
that's the best answer. Now, you could certainly use 2.4 instead of 17 over 5. That doesn't change anything. But to convert it to a decimal means you have to round it off to some number of places. And I don't see any instructions on how many places to round it off to. Do you have a standard? Does your teacher have a standard, like always round it to the hundredths place or something?
He says round it to 4 decimal places, so I think that's the thousands.
It's
I
actually
think
the 10,000.
10,000s. Yeah.
This is hundredths. So this would be thousands. This would be 10,000ths. So what
Right.
are the other two decimals here?
6, 2.
Okay. If her grandparents want her to have 15,000 after 17 years, how much would they need to invest? So give me the equation for that.
So it would be 15,000 equals P E.
Hold on, not quite. What precedes e to the RT? What's that called?
The investment.
That's the starting amount. A sub 0.
Right.
A sub 0. You can't ignore it because that's what they're asking about. That's going to be our variable that we're going to solve. Okay, they give us everything else.
Right. E. So then
17 years.
6 and 17.
So
So
A is equal to 15,000 divided by E. What's 0.06 times 17?
1.02.
So there's your answer, whatever that comes out to be. That solves for a sub 0.
Into 1. So,
What'd you get?
2.7732.
Does that sound right?
Yeah.
I don't think so. 2,000 is not going to grow to 15,000 after 17 years. So, in other words, that doesn't sound right. Divide 15,000 by e to the 1.02 power. E to the 1.02 can't be much more than 2.8. So I'm dividing 15,000 by 2.8. I'm not going to get the number you gave me.
Okay, it's 5,408. I missed a step.
408?
Yeah, point 91389. But
Okay. You just experienced the beauty of ballpark testing
yeah,
because it allows you to catch mistakes that you make. In other words, especially with all the other information they've given us, 5,000 grew to 12,000 after 15 years.
right.
And it took 20 years to grow to 17,000. But if they want to get to 17,000 in 17 years, they got to up the original investment. So it should be a little bit more than 5,000. Not a lot more, a little bit more. But the first answer you gave me, and I'm not even sure what it was, I just know it had a lot of twos in it, could not have been correct. Didn't pass the ballpark test.
Okay.
All right. The last one.
Yep.
Notice what they're doing. Every single one of these questions, they ask you for a different variable. That was the first one we solved for. That was the second one we solved for. That was the third one we solved for. And now we're solving for the fourth one.
Okay.
Okay? That's all they're doing with each of these. And you definitely want to be able to solve for each one, because there's only one variable in all four questions. Okay, so give me the equation I need to write.
So 24,000 equals 5,000 times E, and then to 18R, right?
Yep.
Or
No, that's exactly right. Okay, now next step. What do we have to use to solve this?
divide by 5,000.
Well, and then what do we have to do? We're going to have to use what?
Logs.
Okay. Let's see. 20. I can immediately do that. I'll just write it as 24/5.
Okay. So then the ln both sides, natural log both sides. So ln of 4.8 equals 18R, I think. Yeah. And then so divide that, or divide natural log of 4.8 by 18. Natural log of.
Now, I left it that way for a reason, because when I get down to the end, I want a single expression. Okay. You don't really need to convert that to 2.8. I suppose that it might make it a little easier to get the final answer, but you can do that in your calculator also. You can do natural log of 24 divided by 5, all divided by 18. It might be a little tricky with the TI-84 calculator. You got the Inspire, don't you?
No, it's a Casio.
Okay. Yeah, I don't know how tricky it is. I'm not familiar with the Casio as to whether you have to keep track of your parentheses or not. The beauty of the Inspire is that it shows you exactly what you're typing, as opposed to the TI-84, which doesn't. You have to put in the parentheses just perfect, and it doesn't tell you how you put it in. So it's really easy to make a mistake. I don't know how the Casio works, but
Okay.
depending on the calculator, you might want to turn that into 2.8 just because it's less likely to make a mistake now.
Right.
So
I had a question on 5. I wasn't sure if I did it right, so here I'll send you
okay.
5.
Yeah, if that was 8, 9, 10, and 11, I got to think 5 was not as hard as those. So
Yeah.
of course, if it's a different compounding rate, it could be different. In other words, if it's annual compounding or something.
Yeah. It is sending. And it's sent.
Okay, got it. Yeah, it doesn't take long. Once it says sent on your end, I generally get it within a few seconds.
Yep.
As long as the internet's fast. Sometimes it's not so fast. Okay, number 5.
Yes.
Hmm, 5 is linked with a previous problem.
Right.
And I can't read the previous problem. Can I if I scroll down? No, you didn't get number 4. Perhaps you can read the top line of 4.
Yeah.
And
So
19, I can actually read it. It's behind my black thing. In 1963, the number of cars in the U.S. was about 1.7 million. By 66?
88.
1988, it had increased to about 2.9 million. Write an exponential function in the form of y. Oh, there. So all I had to do was. Now I see what's going on. All right, so we want our equation to be in this form here. Always start with the general form. That's the easiest way on any math problem. Okay, and what we have to figure out here is what A and B are.
Right.
Okay, so Y is the number of cars based on an A and a B. So let's see. By 1988, it had increased to 2.9 million. So what equation does that give me?
So y equals 1.7.
No. Y is the number that it increased to.
So 2.9.
Mil
Yeah.
equals, what was the starting number?
1.7.
Times a b that we don't know yet, but we know how many years. 25.
So I did get. Okay.
This is also mil. Okay, so there's our equation, and there's only one unknown, b. So this is going to let us solve for b. So go ahead and solve for b.
So 1.706 equals b to the 25th.
And you solve for that for b.
And then so that is 1.002.
So you took that to the 1/25th power?
Yes. Here, I'll do it again real quick, just to make sure.
I don't know, that sounds a little low actually. 1.002. Even to the 25th power, I wouldn't expect it to get all the way up to 1.7, but I might be wrong. Where are you getting the 1.706 is 2.9 divided by 1.7?
Yeah, so
Okay.
it's actually, hold on, I think I did it wrong. So 1.706.
You're taking 25th root of that.
I did do it wrong. So it's, yeah, the 25th root, so it's 1.0216.
Yeah, that sounds a little better. So that's b. Okay. So now our equation becomes this. Y equals from a that we haven't figured out yet. Hold on a second. No, I guess we do have our equation. Yeah, and we now have everything. Y is equal to 1.7 times 1.0216 to the x power. Here's our equation. In other words, we always are going to start with the 1.7, so that doesn't change. But the final number is dependent on the number of years that have gone by. But we had to figure out b first. Given the information they gave us, we were able to calculate b, which is this number right here. Okay, so now let's do the rest of them that are, let me get rid of all this stuff here. I want to leave, there's our equation that I have circled. That's the equation that applies to this problem. Suppose the number of cars continues to grow at that rate. Estimate the number in 2005. So give me an equation.
So it 1.7 times 1.0216 to the 42nd power.
37 and 5 And what's that equal to?
So 1.02, or hold on.
Yeah, always do this part first.
Yeah. And 1.0216 times 1.7. So
now you got to take it to the 42nd power before you multiply it by 1.7.
right. Yeah. Oh, oops.
That's what you were doing wrong before, I think.
Yeah. So
that exponent only applies to the 1.02.
raise to 4.
Apply to the 1.7. So you can't multiply them first, ever.
All right. Okay, so it's 4.171.
Mil?
The next one's a 0.
Million?
Yeah.
Okay. That's the units on your start. Okay. And
All
that's
right.
basically what in other words, once you come up with the equation, and remember, whenever you come up with a specific equation, you still have the y and the x in there, always. When an equation is of the form y equals ab to the x, you got to figure out what a and b are to come up with the general equation, or I should say the specific equation that applies to cars.
Okay.
Okay?
All right.
Anything
So
else?
that's it.
Okay. Sounds good. I've had a long week. I'm sure you have too. I don't mind half hour, although I'm feeling a lot better tonight. It's a good thing. I sure felt miserable the other night.
Yeah, I'm glad you got better.
Yeah.
That's good.
I'll talk to you next Tuesday.
Yep.
Bye-bye.
Bye.